Hello all, welcome to Public Cloud Design Tips and Tricks again. Today's topic is Azure microservice pattern. What is the problem statement here? The problem statement is how to achieve time to market and enhance velocity of feature development. I've tried to divide design patterns into different sessions so that it is easy to go through. Now, before we jump into different design patterns, let's discuss why microservices and its effects. So, a microservice always enhances the speed of development. It always enables development teams to work independently, and it decomposes a functional area into smaller boundaries or smaller units to reduce the dependencies among each other. Now, due to this division or due to this decomposition to smaller units, it also brings different complexities and challenges to deal with. Now, how it looks like in a simple scenario. Here, there are different microservices 1, 2, 3, 4. They are attached to gateway at the top. When I say gateway, it is API, it could be API gateway, and each services are attached to their own line of downstream services. For example, service 1 is connected to database 1, a SQL database 1 could be. Service 2 is connected to another database DB2, can be SQL, NoSQL. Service 3 is connected to a different messaging service, and service 4 is connected to an external API. So these are different flavors of microservices. Now, this is a reference architecture of how the patterns looks like, and this one I have taken it from Microsoft documentation sites. You can always refer to the link provided here from Microsoft. And whenever you are designing a microservice kind of a architecture, you will always more or less come across different kind of design pattern depicted here, either in cloud or non-cloud platform as well. So patterns like gateway offloading, gateway routing, and gateway aggregation that always comes within API gateway boundary. When you are developing a microservice, you can come across different patterns like backends for frontends, sidecar pattern, ambassador pattern. These are normal patterns within microservice. And when there are two systems communicating with each other or two services communicating with each other, you can always come across anti-corruption layers kind of pattern. So these are few examples. Let's discuss one by one. So the first one is ambassador. Service mesh we have already discussed in different previous sessions is the best example of ambassador design pattern. So there are two services here as an example, service 1 and service 2. You can say two microservices communicating with each other, and there is a sidecar proxy running in between them, which is dealing with routing, security, circuit breaker monitoring, these kind of non-functional aspects that is isolated from the functional services as a sidecar proxy. So that is how it looks like. So the benefit of sidecar proxy or benefit of this ambassador pattern is decouple network responsibility from functional service. It decouples the security related aspects. For example, TLS offload is one example. It also decouples the scaling and health checks responsibility. It always gets implemented as a sidecar proxy, and it normally used in container orchestration platform as a service mesh. So that is how it works. Now, what is an anti-corruption layer? Anti-corruption layer is always a facet sitting between two systems. Okay. So what originally it comes from domain-driven design pattern, and it implements a facet layer to services or systems. And what it does, it has its own logic to translate the requirements for both the systems. Okay. So for example, when system 1 is talking to system 2, then system 2 has a different requirement as an input. Okay. So the responsibility of this facet is to translate between two semantics. Okay. So that is how it works, and how it gets implemented. It can be implemented as a utility within the calling service, or it can be deployed as a separate microservice. Okay, as a uh, as a third microservice. Okay, when you are talking from one system to another system. So that is how it works. Now this is a very important design pattern, which is backends for frontends. So BFF is always meant to service each client type to connect to the downstream functional services. So what does it mean by client type? A client type could be different channels. For example, let's say you have a downstream service you developed to serve the request from different channel like desktop channel, mobile channel, IoT channel, or some XYZ channel. Okay, so that is more about the client type. Okay, now what it does, it creates always a delegation layer between a consumer layer and a service layer. Okay, and it always optimizes the backend requirements for a specific interface. Okay, so the example I explained, that there is a user interface for mobile or an user interface for desktop, so they both have different kind of requirement. Okay, so BFF is a delegations within that user interface and the downstream service which deals with or which caters the requirement of the user interface basically, or the channels. So that is where it comes into picture. Now, what is a bulkhead? Bulkhead is always used to enable services fault tolerant. Okay, so if you see in this diagram, there are different consumer accessing to the same service. Okay, so instead of now there is a dependency of the same service to different consumer, what we have done here is we have created different instances of services. So what it means, when you create a instance of a service, it always creates its own instance of the ecosystems. Okay, for example, let's say service instance 1 is using a connection pool, so it will never depend on service instance 2 connection pool. So that is where it creates another pool of ecosystems within that instance boundary. Okay, or with the microservice boundary. So what is the benefit of this? It always minimizes the consumer impact in case of a service failure. Okay, so for example, let's say the service in instance 1 gets failed due to some reason, then the consumer 2 and consumer 3 will never be impacted, and they will keep continuing with their own instance of service like 2 and 3. Okay, so that is how it works. Now, partition of service instances with required resources isolate the scope of consumers to service level that we have already discussed. Now, coming to gateway aggregation pattern, where it is always used to minimize multiple round trips between consumer and providers. So, what it means, let's say there is a consumer who has a dependency with 3 services, 1, 2, 3. So, what it will do, it will always first go to service 1, and then based on the response of service 2, it may go to service 3 or service 2. So, this creates all round trips and it generates latency. Okay, so to minimize that, we always have a aggregator pattern. So what it does, aggregator pattern is again deployed as another service that actually do the aggregation of different response into one unit. Okay, so that so the advantage of creating that particular kind of a pattern is it always minimize the latency and it enhance the response. So it enhance the response or the performance of the trip basically for the microservice request response paradigms. So that is where gateway aggregation patterns comes into picture. Okay, so these are few design patterns we have discussed in this session, and we will continue in different other sessions about other design patterns as well. So you can always go through the reference from the Microsoft that I am following just to understand or deep dive more into that. So let's wait for the other sessions also to discuss more about the rest of the patterns. Thank you and have a good day.